Hi, this is Dr. J. Bailey, and in this video, we're going to go through some past IB exam papers related to topic 5.2, which is all about evolution, the natural selection, antibiotic resistance, and anything else that comes through this long. So let's go ahead and go with the first question. Here's one of the questions that happened in previous IB exams, and it says briefly explain the Darwin theory of evolution. So when it comes to Darwin, he's all about the survival of the fittest. Every time you see Darwin, think about that. That means whoever has the best trait, right, will survive. Now, will survive what? Something in the environment that pops out. So something in the environment is pushing them, which we know this as an example of a selective pressure, right? It's a selective pressure that is coming from the environment, and the only one with the best trait will survive, while the bad trait will die. But then that's not enough. You have to mention that once they survive, they need to pass their gene to the next generation. If you don't mention this part, you don't get the point. So it's very important that you have to mention that that gene has to be passed to the next generation. Now, besides all that, if you notice it says the word best trait, so that means there has to be a variation of traits, because if you only have one trait, right, how can you say that's the best if it's the only one? So you have to have 2, 3, 4, like a variation of traits. And out of those traits, maybe one is the best while the other ones will die. So there always needs to be a variation in the population in order to have the survival of the fittest. And of course, when some selective pressure comes up, there's going to be competition, obviously, right? There's going to be a competition between the people. And the one who has the best, strength or the best trait will win. So that's what the theory of evolution for according to Darwin is. So let's look at the mark scheme. What are the things they're asking for? So the first thing they do is see the parents produce more offspring that can survive. Obviously, this is where the competition is going to happen. Here, there's a competition of members to survival, see? So when you have many traits or many offsprings and not enough resources, they start to fight each other. And then, again, you have to say that there is a show of variation. That means there has to be a variation in the population. Now, because of this variation, there will be a certain variation that will be the select advantage. That means, again, survival of the fittest. That means there's that one specific variation in the population that will survive. Now, depending on the environment, that means that's the selective pressure. We're saying something happens in the environment, and then this is where they start the competition, the struggle to survive. And of course, once you survive that, then that variation will be passed on. And he has to say, you have to mention it's passed on to the next generation. Because what's the point of you surviving and then you die? Well, that gene dies with you. So you have to pass that gene to the next generation. So this is the theory of evolution of Darwin. This is the mark scheme, and this is a very sum up, concise mark scheme that nails the points every single time. So make sure to mention about the variations, make sure to mention about the competition, make sure to mention about the survival of the fittest, and all the other verbs. And here, of course, leads to a change in the allele frequency. What does that mean? So let's say you had 1, 2, 3, 4 different traits, right? But then there was an environment that came in here, and then it killed these guys. But then one survived, and then one started doing what? Producing more himself. So look, now the frequency has changed. It was one allele, and now we have many alleles of the same thing. So that's what it means. The population now has a new allele frequency. That means a new occurrence. There has a lot more of that gene. That's what it's the whole purpose. And this is when the evolution happens. When you have a new population with a new frequency of genes, that's when you see a population evolution. So now here I'm asking you outline 4 types of evidence in which support the theory of evolution by natural selection. So they saying the word evidence. This can also be a question that can be found on 5.1, which is the evidence of evolution. And there's so many evidence. We have, for example, the homologous structures, right? Example, we have the pentadactyl. The second thing, we can talk about DNA and proteins, which we usually say these are the biochemistry. We can talk about fossils, right? Fossils is another example. We can talk about selective breeding. We can talk about, let's see, vestigial organs. These are just a couple examples of evidence, but they're only asking for 4. So you mentioned these, you can probably get the point. So let's look at what the mark schemes option gives you. Geographic distribution, that is true. Changing lands, it changed their ways. So for example, this can be like the beaks that comes from the birds. If you remember the story about the bird being in that one island with a certain type of food, and then some kind of environment changes and some birds fly to different islands, and in these different islands they have different food, right? And because of that, what happens to their beak? Their beak changes. So we have different types of beaks here, and that means we have different type of species. That's a geographical distribution. So here says a ring species, other evidence from geographic distribution. So here is just showing you what I just drew here is an example. So you can talk about the Darwin finches, about how the beaks of each of these birds changed as they went for different islands. The biochemistry. When I say biochemistry here, I'm talking about DNA and protein. These are also evidence of evolution. Fossils, as I've mentioned, homologous structures, and the pentactile limb, and resistance to antibiotic. That's another one that is very heavily mentioned in 5.2, all about antibiotic resistance, which you see in the future slides, which there's questions about antibiotic resistance, so you have to understand about the antibiotic resistance. So these are all the evidences that you can list here. Now you just need 4, of course, because it has 4 types, but the more you list, the stronger chances of you getting all the points. So do not be the opposite. Be very generous on your answers. So if here is asking for 4, always put 6, because you never know, you get more points, or if you made one wrong, you still have another chance for the other one, as long as you don't contradict yourself. So next question here says outline or describe. Now outline is more briefly. When describe, you can even draw if you want. And here shows antibiotic resistance and antibiotic resistance in bacteria in response to the environment. Now, even though the questions look different, they're asking exactly the same thing. Talk about the antibiotic resistance. So I'm going to explain again one more time, how does the antibiotic resistance work. So here, let's say you have bacteria 1, you have bacteria 2, and you have bacteria 3. So these are variations, as you can see, right? You have to have 3 types or even more. There's so many different bacteria. These are variations. It has to happen in the population. Then suddenly, out of the blue, we hit an antibiotic. Now, what is the antibiotic? Antibiotic. Oh, I even wrote it wrong here. Hold on. So antibiotic is like a medicine, right? And this medicine here usually kills bacteria. It kills the cell walls of the bacteria. It just destroys it. So this antibiotic will try to destroy these bacteria. So you give the pill out. Now that pill is thrown between these bacteria. Now out of this, let's say bacteria 1 dies. That means the antibiotic did work on it, and let's say bacteria 3 also dies because the medicine worked on it. But when it comes to number 2, it was actually resistant. So I'm going to put here word resistant. What does that mean? That means it was resistant to the medicine. It did not die. Now 2 survived, and now he goes and reproduce, right? Why? Because he wants to continue his legacy. That means he wants to pass on his genes. So now I'm producing a lot of bacteria that have the trait of the 2. So look what happens. In the old days, the population was made of 1, 2, and 3, right? 1, 2, and 3. However, the population is only made of 2. So you can see that the evolution has changed, because the population used to have 3 types of variation, right? 1, 2, and 3. And now, after the environment, which is the antibiotic, came in, basically only the 2 survive. So now you can see the population has changed its frequency. It only has right now a new type of population, which is just made of 2. Now, here's the very important thing to know, is that sometimes doctors say when you get an antibiotic, you must take it for 5 days, and you cannot skip that pill. That's why it is very hard for you to get antibiotics in the pharmacy unless it has been prescribed by the doctor. The reason for that, if you do skip for 1 day, okay, let's say just 1 day, Like there's a certain, like you have to do every 6 hours or every 8 hours. If you skip one time taking that pill, so let's just say you have some extra ones that are still trying to survive, as well as some of the threes are trying to survive, right? The 2 has a plasmid, right? And if you remember, plasmids are found in bacteria and they're made of DNA. So this is where they have the information to make themselves resistant. So in that one day of sparing, you are allowing that number 2 to send his information to them, as well as these. So when the number 2 is sending their plasmid, which is sending their DNA information, here's the killer. That means the next day you go back to the pill, guess what? You can't. Now these number 3s and number 1s have learned how to resist themselves. So that means that pill won't work. This is why we don't just throw antibiotics out there. It's a weapon that we have to be very careful, because if we don't play the weapon really well, imagine all the bacteria in the world now becoming resistant to all the antibiotics that we created. That's why it is only given by doctors. And if you get by the doctor, you really have to follow it through. Otherwise, we lose that weapon to the bacteria. So now let's look at the mark scheme. As you can see, these two questions are asking exactly the same thing. But as usual, IB never give you exactly the same mark scheme. Some mark scheme will have things in common, and it will have some sentences that are not in common. So looking from here, we can see, for example, the first one, it says, the problem results from excessive use of antibiotics by doctors and veterinary livestock, or low antibiotic doses taken by patients not finishing the treatment. This can be found here on age not finishing the prescription in appropriate prescriptions. So these two match. So you can see the A and G matches 1. The next one says, natural variation exists in the population of bacteria, making some resistance to specific antibiotics. So here on the second one, you can say some viruses are more resistant to the others, so they do match. Variation arises from mutation. Antibiotic resistance can be transferred between bacteria by plasmids. So let's see if there's anywhere that says anything about... It does say here alleles of resistance can be passed from one cell to another by exchange of plasmids, but it did not mention anything about variation. So you can see that the part here saying variation has not been mentioned on the second one. The antibiotic kills bacteria except those that are resistant. Let's see here, environmental. So you can say here, if bacteria without resistant die, resistant bacteria survive and pass on the genes. So that can go, because here says resistant survive and reduce and pass on the genes. So these two can be combined just on this one right here. And then some population made of mainly antibiotic resistance bacteria. Soon population is made only of antibiotic resistance. And let's see here. You can say the results in change genetic makeup population. You can see here, look how, not this one. Let me put another color. You can see soon population is made of mainly of antibiotic resistance and the results in change genetic makeup population. Now, these are not exact words, but they're talking about the same thing. They're just saying that the population now has a new type of bacteria that is resistant to antibiotic. And then here on the next one, it says, this is an example of natural selection. In this one, you don't see anywhere saying natural selection at all, right? And here says that the individual will be better adapted to the environment, the one that has the best frequency, right? The best trait will have basically the frequency rise to that. So what are the things you can see here is that some of the ones in the bottom do not appear. It doesn't say anything about antibiotic resistance can be inherited. It did not say bacteria reproduce very rapidly, have high mutation rate. It doesn't say evolution can occur rapidly. Increased exposure to antibiotics in the environment is the environment change the selective resistance. It doesn't show any of that. So you can see on the bottom one, the green ones are the additional words or sentences that you do not find on the top one. This is why we say match mark schemes together. So things that we're going to see in common here, and I'm going to put here, highlight them all again, so you can see what they have in common and what they don't. So this is how you study. You get to match basically mark schemes. So I can say this one right here, as well as this one, these ones, all of these eventually, right, are basically matching with this one. Some varieties resist to others. this one right here, as well as this one and this ones. So these are matched. So you can combine them together as one. And then you have the additional one, which is this one, and these guys right here. So what would you do? You basically would write one mark scheme in which you cancel the blues and then you add the greens, and then you have the perfect match of a mark scheme. So the first thing I would mention is about having different variations, right? And then you can say that the variation rises from what? Mutation. And you can also talk about how antibiotic resistance here, the alleles can pass from one cell to another by plasmid conjugation. And you can say that some varieties are more resistant to others. And that means then you talk how antibiotic kills the bacteria, all the bacteria except the ones that have the resistance. And then if you do have resistance, that means you pass your genes to the next generation. And that means with time, the new population will be mainly of antibiotic resistance, which is the same thing as this one. And then you can add with this how bacteria can reproduce very rapidly and have high mutation rates, and the evolution can happen very rapidly. And increased exposure to antibiotic is the environment change that selects the resistance. So antibiotics can be inherited. So you just add in this information, and this is example of a natural selection. And of course, you have to make sure that you drinking the antibiotic appropriately, because if you don't do it the right way, then the chances of all the bacteria resisting the medicine will be higher. So this is how you would match them together. Now, here is another question that is asking exactly the same thing. But here, it doesn't say the words as these do right here. I'm going to show you in the highlight. If you look here, it says antibiotic resistance, and here it says antibiotic resistance. These two questions mentioned clearly. But on this one, it does not say about antibiotic resistance. It just say it changes the way, but it's still asking the same thing. Look, it says describe the risk of human population indiscriminate the use of antibiotics. So it's asking the same thing about the antibiotic resistance. Look how the mark scheme can match with the previous one. So let's see, where is this? Variation exists naturally in the population. That was in the previous mark schemes. Bacteria that are not resistant to the antibiotic will die. Only resistance will survive. This characteristic could be passed on to the next generation. Like I said, the one that has the best trait moves on. Natural selection leads change the proportion, the frequency. So this is where you say the frequency is changing the population, a new evolution is happening. And then, let's see, population will be exposed to antibiotic resistance and will not have antibiotic to kill them. Nope. Antibiotic resistant bacteria may pass resistance to other. Here, look, the antibiotic resistance may pass resistance to other bacteria species by plasmids. So this is also found in the mark schemes of the previous one. So out of these ones that you're seeing here is the blue ones. These blue ones are also found in the blue ones of these ones, even though the question looks different. So the only thing they have in addition here is antibiotic block bacteria process. That's basically saying antibiotic kills the bacteria. How does it do this? They stop the cell wall formation of bacteria, so they destroy the wall of the bacteria. And they say here, human population will be exposed to antibiotic resistance and will not have antibiotic to kill them. So that means if you're playing with the antibiotics and you're not doing it the right way, then we're going to lose those antibiotics. So looking at these three questions, you can see they're all asking about antibiotic resistance. And you can see in blue, there's the common between them, but there will always be some greens in which they'll be different. So if you combine these three together and basically cancel, the blues and make it as one, and then the greens you add to them, you have the perfect mark scheme. And if you know this mark scheme, every time you read the question that says antibiotic resistance, you already have the perfect mark scheme to put there, and there's no way and no chances that you will lose those points. So moving on to the next question, says, list two causes of variation within the gene pool. Variation means we have in different traits. Obviously, there's two things that can be mutation meiosis, random fertilization, or sexual reproductions. Now, in this question, they're putting sexual reproduction, random fertilization, and meiosis, which these two usually basically random fertilization can happen, meiosis. You can also have crossover, but these are all considered as 1 point and mutation is 2 points. In some mark schemes, they will actually put this as a 3rd point and this will be as a 4th point. So the mark scheme can change. But all of these 4 words, as well as crossover being the 5th one, all of these can be points that comes to variations within a gene pool. However, look at this one. It says no mark for crossover, unqualified. See, sometimes they will not give that point, which is in some other mark schemes, they do put crossover. And it says reject natural selection, evolution causes variation. So it's very interesting that sometimes IB does change the mark schemes. But here's the most important thing. We do mention, if you mention meiosis and mutations and sexual reproductions, these 3, meiosis, sexual reproduction, and mutation, there is no chances that you will get any points wrong for these 2. Okay, sometimes crossover they accept, sometimes they don't. But these 3, there is no chances that you're going to get the points off. Now here, describe how variation contributes to the evolution of natural selection. It's another question just about this. But of course, it says describe, so that means you got to go more in detail. So obviously, you're going to mention here about meiosis. You're definitely going to mention about sexual reproduction. You can also mention about mutation, because these are the mutation, these are the things that causes the variation. Then after you talk about that, variation here, after that, then you talk about the survival of the fittest, right? The one who has the best trait will survive, and if he survives, he passes on gene to the next one, and that's how you have the natural selection in which the evolution happens in the new population. So let's look at the mark scheme. So variation is a different phenotype or differences between individuals in population. That means we're talking about different traits. So the word phenotype here, if you say different traits, it's also okay. Struggle, competition to survive, that is true, right? Different traits, the one who has the best trait will survive. So this is the survival of the fittest. And then some individuals have advantage characteristics. And of course, they have greater chances of survival, as we mentioned. And then the ones who have the favorable allele, what they're going to do? They're going to pass on to the next generation. Now, be careful. Do not say pass on phenotype. Why? Because we don't pass on the trait necessarily. We pass on what? The gene. It is the gene or the allele. And this is where students make the mistake. Whenever you're going to say that something's passed on from one generation to another, do not say trait. Do not say phenotype. Be very specific. We are passing the DNA, and that means it's the gene. That means it's the allele. So every time you talk about this in any assay, make sure you're saying you're passing the gene on or you're passing the allele, not the trait. Because when you say trait, it's like, let's say you dye your hair red. You cannot pass your hair red to your child. You can only pass the gene that is within you that started with a black hair. So it's the gene or the allele that is passed on to the next generation. And these are eventually the questions that you find on section 5.2. Here are some of the future questions, like the beaks of Galapagos, also how reproductive success of a better and less adapted individuals, and selective pressure, the exon variations, like the different types of selection fractions we have there, such as the food, such as the habitat. So these are future questions that you can also find in my lecture video. And this is pretty much it for 5.2.